Hello, everyone, and welcome to this Scaleway webinar. We're really excited to welcome you today to talk with GreenoSoil, which is a super innovative green tech startup. Why are we organizing this webinar? It's because they have a great story to tell. Because not only did they save 8 times on their cloud cost by moving from their previous cloud provider to Scaleway, but they also really have this really innovative application of AI to help farmers to move more towards regenerative agriculture. So we're going to be hearing all about that. Firstly, from with a business sort of context overview from Vitalie, who's the founder, and then we're going to go on to a technical deep dive with Andre, who's GreenoSoil's CTO, and my colleague Diego, who'll be who'll be handling that technical part. And then at the end, we'll be answering your questions. So feel free to ask us those questions. There's a little questions button at the bottom of the screen. That's the best place to ask your questions. You can ask them anytime, but like I said, we'll answer them at the end. So that said, we're going to get on with the webinar. It's about GreenoSoil's success story, as you can see, and let's get the slides moving. Just to quickly introduce Scaleway, you probably know who we are. We're a European cloud provider, and we're specialized in ensuring that technology companies' SaaS experience is as fluid as possible, using fully European and sustainable tech. So European as in is super important because your data is sovereign and safe with Scaleway. It's immune from extraterritorial legislation. That's always a hard thing to say early in the morning. And we're also part of Iliad Group, which is a big French telecom company. And you've probably just seen we've just made major investments in AI. So that's something that we'll be talking about in the case of GreenoSoil too. We're also super bullish about sustainability. We think it's our responsibility to do all we can to minimize the impact of tech on the planet. So we have data centers that use way less energy and considerably less water than other data centers. We work hard to limit the impact of the hardware in those data centers. We only use renewable energy, and we're working right now on allowing our clients to be able to measure specifically the impact of their cloud usage. So watch out for that soon. And I think this is a good transition to start talking with Vitalie right now. I gather that this sustainability aspect of Scaleway was one of the big reasons you chose to migrate to us, Vitalie.
Yes, actually, yeah. Thank you very much, James, for introduction, and good afternoon or good morning to everyone. So yes, indeed, sustainability has been one of the key parameters we've been looking for, because it would be strange for us, a company focused on sustainability in agriculture and climate tech industry, and to use a data processing provider that would use like any other kind of sustainability. And I was amazed to see that 100% of that is used. And it's very, very important. And I would like strongly recommend to anyone to pay attention to that, because there is a big movement. Everybody's talking about EV and things like that, but you need to ask the question from where the electricity actually is coming from. And that's very important. And the second is the cost, obviously, because for any startup, the cost, especially for data processing, is very important and is a competitive advantage, because a lot of startups, at least in our industry, are getting out from the industry simply because they cannot pay the checks for that. And we process a lot of data. So having both sustainability and costs as a competitive advantage is really key to us and to talk to our clients. So let me go into our part of the presentation and to tell you a little bit of what we are doing. As I said, we are a climate tech and AgTech company, and we are really focused on the food value chain, but also on the fuel value chain as well right now. And we help to decarbonize and to promote the regenerative agriculture movement, trying to solve both issues, agriculture and climate. And we think that lack of data should not be an obstacle for that. And that's actually the key factor to success, to understand what actually is going on in any field and how it impacts the climate. So what we're doing, a very simple illustrative example is like to understand that this is what is not a regenerative agriculture. It means the like aggressive tillage, monocropping, use of chemicals that leads to soil degradation, to erosions. And as you can see, like annually, we are losing almost like the surface of United Kingdom in terms of fertile soil. That is really very important, and it goes to the CO2 emissions and also to impact on agriculture. And this is what is a regenerative agriculture, meaning that we need to keep the soil, we need to keep the soil covered, to use more crop rotations, to keep the biodiversity, I mean pollinators, and the regenerative grazing. Always everybody's asking, like, should we eat the meat or not? Yes, you should if it's a result of regenerative grazing and agroforestry, but it's also a very big impact for deforestation. So what is our idea is like to serve pretty much 3 types of clients. Is the entire food value chain. As you see, it's a very big one, starting with farmers, the people who are actually producing the food, and then it goes through everyone who sells something to farmer or who buys something from farmer or provide any services. There are many of them, and end up with the consumers, with us, who are buying in retail on the shelves the food, and we want to know what kind of food is this. Is it good or bad for our health? What is the impact on the environment for any piece of bread we have? Why it's important for the farmers? Because the farmers, by joining our platform, they have access to knowledge. There is a lot. Knowledge is a big obstacle in promoting regenerative agriculture, because you cannot say to a farmer, do this or do that, because there is no one size fits all. You need really to understand what to do. You need really to understand what's your soil health and how to protect it, how to increase the resistance. And as all of us already witnessed all of these droughts and rainfalls during the summer, a healthy soil is a big save to all of these issues, because it can protect us from all of that. And also it can improve the financial results of a farmer if their crops are more climate resilient, or they have some incentives from the food value chain. And
sorry to interrupt, Vitalie. Let's focus on. Can you tell us how it works? I think you guys using satellite imagery which you analyze with AI. Why do you do that?
Because there is a lot of data coming from different types of satellites, like radars and opticals, and we're using a lot of AI, and we have our own proprietary models who are processing this data, trying to find out different correlations, and to be able to say, okay, this spectral or radar reflection is a crop, and this crop grows in such a field or such a soil, and that's the CO2 emissions based on this crop. And as you can see, based on this, we can actually identify, our models can identify remotely from the space, like all the regenerative practices that are used, or actually non-regenerative practices that are not used. This is what allows the AI to identify remotely all of these major practices. And
so you're able to say to farmers, you shouldn't, if you want to get best regenerative results, you should be growing this crop in that field, not in the one you're currently growing it in.
We are, yes, that would be the result. We are more like a laboratory, like a blood test, and that goes then to therapy, to like special trained doctors who can tell you what to do. That's what we are also doing. We are telling what's the current situation and what's the dynamics. For example, we can tell to the farmer, look, because you are using these practices for 10 years, that's how much soil you lost. That's how your like climate resilience actually decreased, or vice versa. If you would or look to those fields who actually are using such practices, they have a better yield, they are more resistant. So why you would not consider changing to those practices? So you give them, you advocate with arguments why it is good or why it is bad. And this is very important, because there is a huge lack of knowledge for farmers, because they don't know really. I mean, it's only a hype, it's a marketing, or indeed the regenerative practices are important for them.
Okay.
And to show how it works, the products, for example, like that's actually the what we do is you can locate all the plants, you can locate the fields around them, and actually we can locate what is going on in these fields. Like in any one of them, you can see what are their crop rotation, what are their tillage, what are their cover crops, like pretty much the regenerative practice. And based on that, we can calculate a sustainability score, like 88%, for example. It means like this specific field is mainly using regenerative practices, and the crops that are coming out of it can be used in the food that will be called whatever, like carbon neutral or regenerative food or healthy food or things like that. And vice versa. If it would be like in the red zone, then it means any crops that are coming out from here are not to be considered regenerative, and this farmer has to be incentivized to move into other practices. And what you as a consumer can do, actually, we put on the market an app, and you can use this app for all the products for the companies, like big major food companies that work with us. You will be able, by scanning the product, to get back up to every field where these crops has been grown, and you will have the traceability and credibility that indeed this major company, obviously everybody, the credibility towards major company is quite low from end users, but we can prove that actually it's true that this piece of already of food has been produced regenerative or not. That's what we are doing, and that's what we aim for.
So before we move on to the technical part, just what's in it for the farmers? I gather that food companies pay a premium pay farmers a premium for regenerative food, right?
Yes, they say, okay, if you would grow, for example, I want to produce biscuits, but I want to claim that they are like whatever, neutral or carbon neutral or regenerative, and I want to source wheat or corn from which to produce these biscuits, and I want to know where are these fields that grows them, and then I go to those farmers and say, Mr. Farmer, thank you for growing such in a regenerative way. I give you a 3% premium on the price. Or why are you not growing that? Maybe we need to help you to provide you some financial incentives, to give you some more money, to give you a better margin for you to move into this production. Because if you would move into that, we will buy this product from you with a premium. So there is a very clear financial incentive to a farmer, and he knows who specifically will pay him more for doing this or that. So it gives him a much better stability and understanding in his strategy, what he needs to do.
Great. So it's not just good for the planet, it's also helping farmers make more money using our AI tech. So
you need to motivate them. You do not need to penalize them. That's motivation is more important than penalizing, and that's the way how you can motivate them. Yeah.
Fantastic.
I have a question before we move forward to the technical part, and I think more than one person watching this webinar will have that same question. How do you actually figure out which crop is in which field based on these images? Because they are apparently just images, right?
It's not images. It is called images, but actually, if we remember the physics from the school, like every object reflects the light, right? And that reflection of the light is a kind of a spectrum signature, or it reflects the wave from the radar. And if you can identify that this reflectance from out of a million of other reflectance is actually a corn, then you train the algorithm saying every time you will see this kind of a spectrum of a light, it's a corn. And then you have a range of lights for corn, and you say, okay, if it's on the high, then it's a good corn. If it's on the low, then it's a bad corn, like it's ill corn. And that's how you can even distinguish if it's corn and if it's sick or it's not. And the same you can do with the soil, because when you plow, then the soil has a texture and a color, and it has a different reflection in the spectrum lights. And you can train the algorithm to tell you that every time you will see this, it's a plowing, or vice versa. If it's covered with vegetation, then the reflectance is different. And then you can train the algorithm saying, if you see this reflection, then it's a no-till and it's a regenerative practice. To keep it simple in a way. Actually, that's what I know about technical. So.
Yeah, I would like to add that we have a separate department of people who just focus on the satellite stuff. They are non-developers, so it's a very complicated area. Me and Vitalie we are not such a the biggest experts in our company in that field.
You guys are focused on the platform, which is called Greeno, right? The product.
Yeah.
Yes,
cool.
Exactly.
So this is a good time to transition to the technical part. I'm just going to whiz back to where we were in. So this is over to Andre and Diego to talk about how it works.
Yeah. Okay. Hello, everyone. My name is Andrei Sukhanosov, and I'm a CTO at GreenoSoil. Today, I will be talking about our journey migrating from AWS to Scaleway. The challenges we faced, how we addressed them, and the key considerations during this process. Well, initially, our team included a cloud engineer experienced with AWS, which was a crucial factor for a quick start. So we began building our infrastructure there. Also, at the time, AWS seemed to be the optimal choice in terms of pricing. So, as you see, our infrastructure in general could be divided into two big categories. First category is periodically running data processing pipelines that extract data, that extract a diverse array of data regarding the condition of agricultural fields using satellite imagery and AI. So right now it's fully migrated to Scaleway. And the second, constantly running services that users interact with, where the aforementioned data is imported to. Currently, it's running on AWS. Well, in today's talk, I will focus on those data processing pipelines as they are the core of our business. They represent the most complex and technologically advanced part of our product and have been the source of our most significant challenges. And well, it's the only part that was actually migrated. Okay. Any of our pipelines begins with the optical and radar satellite imagery, which are publicly available for free, but with some cloud-specific nuances. I return to this point later in my talk to clarify what I mean. Well, currently we work with Sentinel-2 for optical data and Sentinel-1 for radar data provided by European Space Agency. Each type has its own advantages and disadvantages. For example, optical satellites are unable to see through the clouds, which is obvious, I think. And radar ones which radar ones are capable of. Also, optical data is ready to be used as is. Just download it and start working with it. But radar data requires a lot of complicated pre-processing. So let's take a look at a simple pipeline as an example. The NDVI calculation algorithm, previously mentioned by Vitalie. NDVI means Normalized Difference Vegetation Index. This index is widely used in remote monitoring of agricultural fields. It's possible to find numerous code samples online for calculating NDVI. Using just two so-called bands of optical satellite imagery. For our example, let's consider France with 2.8 million fields in our system monitored over 7 years with the Sentinel-2 satellite. Suppose we calculate it on an IRM instance with 32 cores. This type of instance is available on Scaleway. We would get approximately these results in terms of time. So one instance will finish in about 60 days, 10 instances in about 6 days, and 100 instances just in 14.5 hours. So it means our example pipeline scales pretty well when we add more instances. It's a case of distributed computing when multiple instances work on the one big task split into smaller chunks. So our goal was to create a variety of such pipelines. When we had the first version of one of them ready for testing, we realized after initial runs and cost estimations that processing everything we had planned at the time was quite expensive. At the beginning, it was just a few European countries, and this was just one of many pipelines we needed to build, and not the most complex one. At this point, we were a bit disappointed and started looking for a solution. There are two obvious ways to reduce computational costs, finding more affordable infrastructure and optimizing the code. We decided to pursue both of them simultaneously. So it's worth mentioning that in the process of considering various alternative pipeline implementations, we naturally needed to estimate the cost of each variation before an actual implementation. This was particularly challenging with AWS due to their complex and convoluted pricing model. I felt like you need to take a few courses and get a PhD just to use AWS for cost calculations. It's really annoying.
I'm sure that's it's a common feeling.
Yeah. So as you see on the left, few screenshots of AWS forms, just a little piece of it, and on the right, the same with Scaleway. So naturally, we considered renting dedicated servers. It's obvious that this approach is much more cost-effective than any other cloud solution. However, due to the irregular, extensive nature of our calculations and the need for a large number of instances for efficient processing, this option was not suitable. We required the flexibility to rapidly scale up a large number of instances when necessary and shut them down after the job is complete. So around the time the first game-changing encounter with Scaleway happened, we didn't know about them at the time. At some conference, Vitalie was approached by Scaleway's representative who suggested we looked into their services. We also were invited to apply for the Scaleway's startup program. As I was looking for a more cost-effective computing option, I immediately registered with them and we applied for the program. They offered us free credits for an entire year to use on any cloud resources they had. We quickly got accustomed to Scaleway's user-friendly and straightforward user interface, realizing that they had all the necessary tools to build our pipelines on their infrastructure. Well, except for IRM instances at that time, which we were keen on continuing to use due to their efficiency and sustainability. But then the second significant event with Scaleway occurred. Before we even expressed our preference for IRM instances, they invited us to participate in some beta test program that allowed us to use IRM instances at the price of a dedicated server. Therefore, we rushed to migrate our first pipeline to Scaleway while simultaneously optimizing it. It was based on a CPU ML model.
Can I ask you here, Vitalie, why did you have this preference for ARM instances instead of regular x86 types of instances?
Diego, I'm the wrong person to ask this question, trust me.
Definitely, absolutely. I'm very sorry, Andre.
Well, I'm sure Vitalie knows the answer to that question because it's obvious. Well, personally, I love IRM since it was introduced as a developer machine by Apple. All of our developers work on IRM machines now, so it's really great way. Great when cloud providers introduced IRM instances available for computational needs, and it's really energy efficient.
All right.
Therefore, sustainable and
exactly
cheap.
Yeah, aligns with what you're doing. All right. And how about its power or its capabilities? Because we are using Ampere's Ultramax CPUs over here. Have you noticed the impact that these CPUs have?
Yeah, as far as I understand, Ampere's are the most superior IRM cores right now, CPUs. and AWS uses their own
proprietary implementation. Yeah.
From mine experience, it's way efficient. Ampere ones way more efficient than AWS's own ARM instances.
All right.
So also this cheap beta program I was talking about currently is finished, and the production ready line of ARM instances is available. So it's called COP ARM in Scaleway. Here is the image of a few of the instances available. Well, next, the third pivotal moment with Scaleway occurred when we needed to develop a pipeline based on ML model running on GPU. We were working on a pipeline for processing radar images. The problem being that they are very large in size. One approach would have been to split these images into smaller pieces for separate processing on less capable GPUs, and then reassembling them, which will be more complex and less efficient. However, Scaleway had just introduced powerful NVIDIA H100 GPU instances capable of fitting the entire image in video memory, saving us considerable time and effort. They are also adding new types of GPU instances on a regular basis, and we are trying to keep up and test everything new for different scenarios. Okay, the last but not least, I would like to highlight our experience with data storage on Scaleway. We utilize a lot of their object storage and S3 compatible solution for storing our data processing results. From a long-term perspective, this was a key factor in our decision to choose Scaleway. Unlike AWS, where cost calculation can be complex, Scaleway's pricing model is straightforward. Simply input the expected data volume when creating a bucket to get an estimate. Well, you see the picture of exactly this in my slide. So we found that storage costs were about 25 to 30% lower than on AWS for standard storage type, not accounting the additional AWS specific parameters. Also, remember I mentioned the conditionally free access to publicly available satellite images. Well, for instance, Sentinel-2 optical satellite data is hosted on AWS S3 and Google Cloud. If you download, maybe somewhere else, I know these two. If you download the images within the AWS infrastructure, you pay nothing. But if you download from outside, be prepared to pay a substantial bill. On the other hand, with Google Cloud, you don't have to pay in any case. So you may ask, why is this? It's due to what's called the cost of data egress. It's a fee for simply downloading data from the cloud, for example, to your local computer or any other external computer for that cloud. Well, cloud providers use this strategy to discourage clients from using resources outside their cloud environment. So it's extremely disadvantageous to rent a cheap dedicated servers and use it in combination with AWS S3. You'll simply go bankrupt. Essentially, if you have a lot of data on S3, you find yourself locked into AWS in terms of absolute unprofitability of using additional external services that could also use this data. Well, therefore, when considering migration from one cloud provider to another, it's crucial to focus on this aspect. You might discover that you need to pay a substantial amount of money just to transfer your own data to another cloud storage, far exceeding the cost of storing the same volume of data. Well, for instance, migrating 1 petabyte of data would cost you about $56,000 US with AWS, compared to about 10,000 euros with Scaleway. So it's 5 times
Quite
less.
a difference, yeah.
Yeah. Recently, Google Cloud completely eliminated this fee, a move I hope Scaleway will also consider in the future. Well, in my opinion, such a step would make them even more attractive, especially for new clients hesitant to try new cloud. And it would also complement their Cosmos Kubernetes, multi-cloud Kubernetes for Scaleway and external provided resources. And in conclusion,
Andre, can I stop you before you go to your conclusions? Because I'm sure at least someone else in the audience is wondering about the satellites. How do you gather those satellite images? Because you mentioned the ESA, and maybe not everyone knows what the ESA is. So if you can go back to one of your previous
European
slides.
Space Agency.
Yeah, can you tell us about that? Nowadays, someone could think that you are sending your own satellites to space.
No. Well, there are different.
Not yet.
Not yet.
Yeah, not yet.
It's doable.
Everything is doable. Look at Elon Musk. I mean,
exactly.
Who would believe it?
Exactly.
Yeah, there are different satellite imagery providers in the world. Some of them are free, like ESA, European Space Agency, just puts it out there, and everybody can just download it and start doing something with it. Some are.
All right.
Some of them are. Yeah.
So if I'm inspired by your presentation today, I can actually start doing similar things with that kind of imagery right now.
Of course. Yeah.
That's amazing.
Yeah. Well, there are also very expensive ones, and it's supposed to be ordered in advance. The imagery is supposed to be ordered in advance, so it's not historically available.
All right. And I also have some understanding that there are private companies out there that will sell specific images from a specific
and it's
time,
very
band.
expensive. It could be very expensive to buy it from them. So we started obviously with free solutions. They are very good, and they cover the whole planet Earth.
Okay, so
it's a great way to start.
One could think that the European Space Agency may just focus in Europe, but they are covering the whole world.
No. Yeah, the whole world.
All right. Thank you for clarifying.
So maybe we could get back to your conclusion, Andre, and then see if there's any other topics.
So our choice of Scaleway was driven by the availability of all the infrastructure elements we require from the technical point of view, of course, and the optimal cost effectiveness for our specific use case. Our desire as a startup to support competition by backing a smaller yet outstanding cloud provider. Well, finally, it's been a fantastic year working with Scaleway. I highly recommend their services to everyone, particularly as those new to cloud infrastructure and Kubernetes especially. That's it.
That's great.
All right.
Thank you very much.
Thank you so much. So I think we have a user commenting while they add their comment or question. I do have a few technical questions for you, Andre. And you mentioned that you do parallelism, right, to optimize the use of your ARM instances. I wanted to ask you, what do you use to parallelize your pipelines? Do you have an in-house
well,
solution? Do you use open
yeah,
source
it's
tools?
on AWS. We started with Spark, and their dedicated service called Elastic MapReduce, if I remember right. But when we moved to Scaleway, we just started to using our own proprietary thing based
All
on
right.
simple queue. We use Redis for that.
Okay. So you use the Scaleway's Redis product.
Yeah.
All right. Let's see if we have any other questions, because if you don't ask questions, I'm sure I have a lot. We have a question from Maxime. He says, how many images do you need for a field to identify its crop, and are miscalculations common?
Well, that's a tricky question, because no one can actually answer it with great accuracy. Well, if you identify a crop, you can identify a crop with optical imagery, with radar imagery, and with combination of both. So if we are talking about optical imagery identification, you need to take all the images the crop it starts growing and ends growing at that period of time. So it's about depending on the cloud situation, it's maybe from, I don't know, 20 images to 60 or 70 images per year.
All right, so it depends on the time period that is also associated with
the cloudiness of this area and stuff like that.
The conditions, and also the period of the stage of the crop, if it's just being seeded, or it's just started growing, or it's in advanced stage.
Yeah,
I'm
about
guessing
the
you will have different reflections, right?
Well, yeah, about the miscalculation part. Well, it depends from the model accuracy with that specific crop. So we try to be in the area of 90-95 currently % of accuracy. So.
And that's a good segue for one other question that I had. How about your AI models? Do you use any other open source models that you adapted to your use case, or did you just start training your things from scratch?
Well, when we started, we was looking for open source models, but as you may understand, that it's that kind of stuff is state-of-the-art AI models, and nobody puts them out there for you to just download if they detect crops really good. So it was out of the question. So we obviously started doing our proprietary models.
Okay. I get it. While Liana ends up typing their question, I have yet another one, which is you talked about the files, right? So you have imagery, optical files, and then radar files. And can you explain a little bit more about those files that you get? You said that the optical ones are just images that you can see, but then the radar images are sets of data, right? Data that you need to process and analyze.
Yeah, they both could be looked at in a special editor, but it's not really a great way to say that radar imagery, you can see it with your eyes. It's out of the visible spectrum. But it could be visualized, and it's stored. It could be stored in the same format. The optical data and the radar data could be stored in the same data format. Usually JPEG 2000 and TIFF.
All right. So would it be accurate to say that you will need to have different images of the same location that are captured with different types of sensors from the satellite to actually understand what's the composition of the soil in the whole area, right?
Yeah,
and you
that's
need to put them together and process it. All right.
Yeah, that's pretty accurate. Yeah.
We have another comment, another question. Liana asks, do you share the data you collect with other agencies who have different research objectives based on the same data? For example, an agency may want to correlate regenerative agricultural practices with better health outcomes for local residents.
I will take this question.
Yes.
It's a very nice question. We are not doing that right now, but we would be very, very interested and curious about this. Like as a consumer by myself, I would be very curious to find out if indeed there is a correlation, for example, because we can identify a region or 10 different regions and to rate them or to grade them according to the regenerative practices implementation, starting from the worst one, like dirty ones, and the most green one, and to do a correlation with different diseases or different health problems that the people may be there who are in a way eating the food that has been produced there. Obviously, a lot of food is important and exported, but you can actually identify some food that is mainly used locally. And then you can say, for example, I don't know, like gut or like problems or like respiratory problems or like, I don't know, like that would be really, really curious, because that would be a very important thing for general public, like to know how the regenerative agriculture is not only helping kind of the nature, saving the planet, but you specifically, like because you are living in such a region or you are eating such food, how it actually influence your health. If you have an idea how to do that, or you have an agency who would be interested, like please contact us. It would be really interesting to do it.
That's great. How should they reach out to you?
Pray to God. You have any contacts? I mean, I don't know. I mean, we can write the contacts here, so and you can. Okay, I can.
In case I'm guessing
that local authorities might be interested in, because if they can say our region has more regenerative agriculture, that would suggest that it's safer it's a safer region for people who are looking to live there.
And that's how you can calculate. And I actually I've heard a couple of discussions like that in US. Very interesting to say they do a correlation between regenerative agriculture and the spendings on the health industry, saying that how you can actually motivate, from where you can take the money to motivate the farmers, right? If, let's say, this regenerative food is actually helping to save 10% of the health budget, like spending less because people are more healthy, and it could be like, I don't know, $1 billion or $1 trillion, then actually out of this, you can partially incentivize the farmers who actually grow, in a way like food is a medicine, right? So that research would be really nice. I'm sure that you need a lot of metadata, but it would be really curious. And as you said, that would be, oh, there is a cat actually. It's, imagine how the prices for real estate may grow up in the zone where everybody will say, oh, actually, it's much better to live here. It's more regenerative and things like that. So a lot of industries can be affected by that.
Yeah, and because people will say, I don't want to live in a region where all the farmers are using pesticides around me.
Yeah. And then somebody will sue us for that.
No, it's just information.
I would buy that information for sure. Yeah.
That's what I said, that if you remember my slide, social control, where you can actually trace the food, but actually it can go much further than that. That's a really interesting. Thanks actually for that. Maybe it's a good product to do actually.
Great. So we've run out of time. I think we've answered the questions that we had. So yeah, that's it. Unless you guys have anything to add before we wrap up, I think we can call this to an end.
Yeah, I would like to thank you, Andre, actually, for his very detailed presentation. I found a lot of new things for me as well, because I'm really I'm like a kind of guys more focused on the strategy and things like that. And thanks for that detailed calculations. That's why Andre is taking care of all the technical details you have to delegate in the company. And I just find out once more, but it was a good idea to move to you guys, actually.
Good to know.
Thanks to Andre, thanks to Vitalie, and we had a guest appearance from Andre's cat at the end, which was fun.
Nature is always near us.
All around.
All right. Thanks a lot, guys.
Thank you.
Thank you
Bye.
for your time.
Bye.
Bye-bye.